Hello, I'm Teacher Omar. Let's talk about the speed of sound. These are the specific learning objectives from the most essential learning competencies. At the end of this lesson, you should be able to describe the effect of air temperature on the speed of sound, compute for the speed of sound at a given air temperature, and explain the different properties of sound. Most people like to listen to the music. Music is an art form and a cultural activity whose medium is sound. Do you know how sound is produced? Sound are caused by vibrations. Vibrations are the back and forth movement of objects. Look at this simulation of the back and forth movement of objects. When we speak, vibrations are produced by the vocal cords inside your throat. You can hear the vibrations when sound waves reach your ear. This is how sound waves is produced using a bell.
When we ring a bell, we cause the metal that makes up the bell to vibrate really fast back and forth. And the vibration of the bell also shakes up the particles that make up the air around it and makes them vibrate. Then those particles run into the air particles next to them, and so on.
Remember this, when an object vibrates, it creates sound energy. Do you know that sound energy travels in a form of sound waves? And sound waves are longitudinal wave and mechanical wave. When we say longitudinal wave, the vibrations are parallel to the direction of the wave. And when we say mechanical wave, the sound waves need a medium in order to propagate or transmit from one place to another. And the media that are needed in order to transmit the sound waves are solids, liquids, and gases. Sound waves travel fastest in solids and slowest in gases. Analysis. If sound waves are mechanical waves, it means that sound needs a medium in order to transmit sound waves from one place to another. The question here is that, can we hear the sound waves in the outer space or a vacuum wherein there is no air particles? And the answer is no. Now, let's talk about the speed of sound. The speed of sound can be fast or slow depending on the type of medium like solid, liquid, or gas wherein the sound waves propagate. The speed of sound can be affected by the elasticity and density of the medium. When we say elasticity, it is the ability of the material to return to its original form after a certain amount of force has been applied to it. If we are going to compare the elasticity of the material, solid are more elastic than liquid and gas. Therefore, the speed of sound in solid material is fastest than liquid and gas. When we say density, it is an intrinsic property that is determined by the amount of mass per unit area of space or volume of the material. The sound wave travels slower in denser object. This factor applies when comparing media of the same phase. For example, helium and air are both gases. Air are more denser than helium. Therefore, the sound wave travels slower in the air and faster in helium. What is it? Let's talk about the speed of sound in the air, wherein the sound that we hear usually propagates. The speed of sound in dry air, which is at 0 degrees Celsius, is around 331 meters per second. This speed gets faster when the temperature is increased. In warmer air, the sound can travel faster. This means that the relationship between the air temperature and the speed of sound is directly proportional. The speed of sound increases by 0.6 meters per second with every increase of 1 degree Celsius. In equation, V, or the speed of sound, is equal to 331 meters per second plus 0.6 meters per second per degree Celsius times temperature in degrees Celsius. Temperature is the degree of hotness or coldness of a material. It is measured using a thermometer with the following units: degree Celsius, degree Fahrenheit, and Kelvin. Let's have sample problem number 1. What is the speed of sound in the air if the temperature is 30 degrees Celsius? Ang unang step, i-identify natin ang given. We have temperature is 30 degrees Celsius. So temperature is equal to 30 degrees Celsius. Pangalawang step, required. Ang question ay, what is the speed of sound? So ang required ay speed of sound. Pangatlong step, equation. So you write the formula for the speed of sound. Speed of sound is equal to 331 meters per second plus 0.6 meter per second per degree Celsius times temperature. Pang-apat na step, so solution. We are going to substitute the given to the formula. Okay, so 331 meter per second plus 0.6 meter per second per degree Celsius times 30 degrees Celsius. Okay, and then let's multiply 0.6 meter per second per degree Celsius times 30 degrees Celsius, and it's equal to 18 meter per second. As you can see, degree Celsius is cancelled out. Yan. And for the last step, we have answer. So we add 331 meter per second plus 18 meter per second, and the final answer is 349 meter per second. So ang speed ng sound at 30 degrees Celsius is 349 meter per second. Sample problem number 2. What is the temperature of air if the speed of sound is 346 meter per second? Okay, step 1, identify the given. We have the speed of sound is 346 meter per second. Next, I required, we have the temperature of air, and then write the equation or formula. We have speed of sound is equal to 331 meter per second plus 0.6 meter per second per degree Celsius times temperature. And then Solution. Next step ay solution. So, we write the given doon sa formula. Okay? So, ang given is speed of sound. So, speed of sound, which is equal to 346 meter per second, is equal to 331 meter per second plus 0.6 meter per second per degree Celsius times temperature. So, ang hinahanap natin dito ay temperature of air. Next step ay i-transpose or ilagay sa kabila yung 331 meter per second. So, dahil positive siya, magiging negative siya dito kasi nag-transpose. So, we have 346 meter per second minus 331 meter per second. Okay? Equals 0.6 meter per second per degree Celsius times temperature. Then, i-minus natin, we have 346 minus 331 is equal to 15 meter per second. Okay? And then, let's divide both sides ng 0.6. Okay? Para ang maiwan na lang is yung temperature. So, let's divide both sides. So, maka-cancel yan. Then, mapupunta dito. We have 15 meter per second divided by 0.6 meter per second. Ayan. Then, cancel out ang units ng meter per second. So, ang maiiwan na lang is degree Celsius. So, 0.6 divided by 15 is equal to 25 degrees Celsius. So, ang temperature ng air kapag ang speed of sound is 346 meter per second ay 25 degrees Celsius. What is it? Properties of sound. There are two properties of sound: the reflection and the refraction. When we say reflection, it is the turning back of wave as it hits a barrier. We have examples. When the sound is reflected, it is called echo. When there are multiple reflections, it is called reverberation. Another example is echo sounding. It is used by the scientists to map the seafloor and determine the depth of the ocean or sea. Refraction. It is the change in the direction of sound waves as they pass one medium to another. The refraction of sound waves happen during day and night. During daytime, the sound waves are refracted or bent upward. And during nighttime, the sound waves are refracted or bent towards the ground, which means that sound are loud and clear at night. What's more, do the activity number 1 entitled Calculating the Speed of Sound. Let's check comprehension. Thank you for watching. See you to the next video.